What is sound? You might say sound is anything you hear, but there are also sounds that you can't hear. This, however, you can hear. The surface of the gong vibrates rapidly. This causes a disturbance in the air around the gong. The vibrating surface of the gong sends out vibrating waves of air, just as a pebble dropped into a pond sends out little waves or ripples over the surface of the water. We call these vibrations of the air sound waves. When they strike our ear, they cause the eardrum to vibrate at the same rate, and we recognize the sound. If we strike a smaller gong, sound waves it sends out make the eardrum vibrate more rapidly. This is a different sound, a higher pitch. The more rapid the vibration, the higher the pitch. Now that was a high-pitched sound, disagreeable to hear. When the rate of vibration per second becomes too high, when it exceeds 7,000 vibrations per second, the human ear can no longer register it. We don't hear the sound. But it still goes out through the air, and we can prove it to you. We can let you actually see sound that you can't hear. We can do this by means of an electrical device. It's the branch tube that changes sound waves into electrical impulses. Well, that in itself should be nothing strange to you. It's the basis of radio and television broadcasting. But the branch tube makes sound visible to you. Now you can both see and hear this sound. But as the rate of vibration rises above the limit of reception of the human ear, the pitch gets higher and we can no longer hear the sound, though we can see it. As the pitch rises, the tops of those circling lines are closer together. And now as the tops of the circles grow wider apart, the pitch drops and we can hear the sound again as well as see it. But how can we produce super sound waves, vibrations of air so rapid that the human ear does not register them? Well, one way is to place a quartz slab between two electrodes so that it vibrates as fast as the electric current changes directions. We use a high-speed alternating current, and the vibrating quartz bar then sends out super sound waves. Now we'll turn on the electricity. Now this sends out super sound waves that we can direct through the air, the way you direct light waves from a flashlight or a searchlight. And we can also bring the sound waves to a focus, just the way we can bring light rays to a focus. You see how we bend those light rays? Well, we can do that with sound waves, too. Of course, ordinary sound goes round corners. This noonday whistle, for instance, turns a corner and tells this workman that it's time for lunch. Here's a proof that we can focus sound waves as we do light waves. This is a focusing device, a concave metal mirror that we're putting in a tank of water. Sound travels through water 5 times as fast as it does through air. Of course, we can't see the disturbances in the air caused by sound waves, but we can see them in water and photograph them too with a special lighting device. You see, if you wave a stick in the air, you don't notice the air waves you disturb, but if you wave a stick in the water, you can actually see the disturbance you create in the water. Well, that's the principle of this experiment. We can see the disturbed particles of water where the sound waves make them vibrate. Now here we are, we're focusing the sound waves. Now those bright streaks are the water particles that are being moved by supersound, and you can also see they're being focused by that metal focusing mirror. Now these sound waves have energy, or they wouldn't disturb the air or the water or anything else. Now we take out the mirror and put in a flat block of plexiglass. Doesn't focus anything. And we'll turn the sound waves in on that and see what happens. Well, now the sound waves strike it, and you can see they just spread in all directions. You could get the same effect turning a stream of water against a wall. You see, the water particles are disturbed, and even after you turn on the sound, the particles take a little time to come to rest. Now, I said sound waves have energy, and here's further proof of it. This is the question of just dropping some earth into the tank, and you can see it would fall naturally if there were no sound waves blowing it away, so to speak. Of course, if you turn sound waves underneath this cup of water, it will make it disturb it just as though it were bubbling. You can do the same thing with oil. Now, here's a way of actually measuring the energy of sound in water. This is a delicate device with a wide, thin plate in the water below and a swinging indicator to show any movement of the plate. Now, we turn on the sound, and it strikes the plate and drives it forward. The indicator above registers the force of the sound. All these properties of sound can be put to good use, as in navigating ships, for instance. Well, let's watch this fellow and see what he has to do with sound. Well, it's an old boyish trick. We yodel or yell, and a distant cliff or hill sends back an echo. We know how fast sound travels, about 1 mile in 5 seconds in air. If we time an echo, we know how far off the object is that sends back the echo. Well, in navigation, a ship can send a sound wave to the bottom of the sea. It bounces back. The navigator takes the time of this traveling sound and knows exactly how far beneath the keel of a ship the floor of the ocean may be. Now, we can use ultrasound for testing the quality of metals, too. A faulty bar will not transmit or reflect supersound waves in exactly the same way as a perfect metal bar. Where there's a difference in what you might call the sound effects, there is a difference in the metal itself, a fault. Well, a worker marks a spot where he gets this sound reaction, or you might call it an unsound reaction. These are the faults in the metal that must be repaired or removed. Another thing we can do with supersound is to mix oil and water. Now, I'm pretty sure you can't mix oil and water. When you pour them together, the oil immediately comes to the top. We even say pouring oil on troubled waters. But if we turn on the supersound, the rapidity of the vibration will really mix oil and water into what you could call a permanent mix. And sometimes we need it, we want it. And with supersound, we can do this on a commercial basis. But the latest use to which supersound is being put is as a healing device in European clinics. Now, we know that massage is beneficial to some patients suffering from various afflictions. Well, supersound is something like a super massage without using the hands. Now, here's this chair, for instance. We fill the whole seating section with water and turn on the supersound from below. The supersound vibrations are transmitted through the water to the body of the patient sitting in the chair. Of course, we can also use supersound airwaves themselves in a smaller device like this, and if you hold your hand over it, the vibrations will make that water in your hand jiggle. Well, as this nurse gives another patient a treatment of supersound, I think we can agree on a few things. One is that what we hear is sound. The other is there are sounds that we can't hear, but we can see them and feel them.